in sets. All right, let's look at a problem here. We'll copy this, we'll go ahead and run it, and we'll see that when I create a class A and I create A5, which is an instance, which I add to a set, then when I see if A5 is in the set, it's not, false. That's a problem, okay? It wouldn't be a problem actually if I did this. And I go ahead and added A. A is sure enough in there. So that works. The issue is when I check if I add an instance and I check if an equal instance is in S. And that fails us. And we want that to succeed. Or at least we want to be able to make that succeed. So the issue here is when you add an element to a set, the first thing that's going to do is hash that value. So like if I'm going to add the word wow to a set, the first thing it does with wow is hash it to turn it into an integer, which is used to determine which bucket in the hash table this is going to be stored in, as we discussed earlier in the course. Now, when I create A5 and I hash that, sure enough, I get some value. When I do hash another A5, I get a different value, and that's the problem. So basically, hash is not working the way you'd want it to. So just as you have to teach Python how to use EQ for equal, you have to teach Python how to hash when you create a set. Pardon me, when you create a class. So go here and we'll def hash of self return 42, and it still fails us. And the reason it fails us is it's finding the right bucket now, but you still must use the EQ that we defined previously, because once you're in the bucket, it tests for equality, as we also learned earlier. So hashing, or that is using a set, requires both equality and a hash function. So now that works, but of course it's lousy because 42 is a terrible hash function. It's going to put all the values in a single bucket, which is to say it's not going to really be a hash at all, it's just going to be a list. So you really want to use a good hash function, one that spreads out the values across a large range of integers. Well, it turns out that if x is hashable, we could just use Python's own built-in hashing on x. And that's a very reasonable way to go about doing this. This works. Generally speaking, you would want to hash on the values that you need in order to tell if two instances of A are equal. Let's flush this out a little more by adding a second parameter here into our init. Self.y is y. We'll do 5, 7 and 5, 7. And now and self.y equals other.y. Now that's how we have to test for equality, because you have to test that the other one's an A and the X's and the Y's both match. Fine. So therefore the hash, you want to hash both X and Y. But that's not going to work because hash only takes one argument. Fine, we'll put them in a list. But that's not going to work because lists aren't hashable because they're mutable. So you put them in an immutable list, that is a tuple. And this is in fact going to work. This works. So now you can see, let's actually do that. You can see that if I'm hashing a tuple of all the attributes that I use in order to test for equality, then my custom hash function is going to work. Custom hash method, to be more precise. All right, so now the last thing we're going to do is create a method called getHashables. And it's going to return this exact tuple, the tuple of the hashable values that I use inside EQ. Now my hash method can be simply self.getHashables. The advantage of this approach is you can literally copy paste that hash method every time that you create a new class. And all you do is update getHashables to right inside there to update this list to be the list of the attributes that you use inside your EQ method to test for equality. And in that way, you can now reliably create classes that can be used inside sets.